ऐसे तो करना है
स्पाइरल यूज स्पाइरल
हां स्पाइरल में किस तरह से अच्छा तूने कर दे कौन आ गया हां तो बदल यहां से मैंने किया तुझे कब दिखेगा लाइब्रेरी में सब पेपर दिखते हैं मैं आ रही थी क्लास इसको देखा तूने वो इसको देखा मैं आई थी अरे है ही नहीं इधर से ना मुझे
जरा बात
अरे सर एक हाथ उठा है आया एक तो जरा पाउच किया तो वॉल्यूम हां वॉल्यूम ये है
माइनस भी करते हैं ना इसके अलग
माइनस करना है
हां
2 minus
2 plus 3 2 minus
ये इधर
माइनस करना
स्पाइरल को
एक और बनाना पड़ेगा
नहीं रे उससे
अरे उसने करो ये
आपने
किया है
इधर तो वापस करना पड़ेगा मैं वो स्पाइरल वाला कर रहा है
एग्जांपल
ये इसमें दिखा ये इधर ना कैमरा ये 90 बना है बोलो
यहाँ कौन 90 बन गया टेढ़ा बनना चाहिए
ये कोशिश करता है मुझे पर सब्जेक्ट है
the average velocity is
उधर किधर पर
क्या
क्या बना ए
बीच में 400
बोलो
कट करना टाइम 8 घंटा
फिर क्या
वो
होगा
नेगेटिविटी कट होगा नेगेटिविटी फिर 8 कट या 14 कट कर ले हां कर
हो गया
यहां से यहां के पास है
घुमा दो आप और नेगेटिव में भी होगा नेगेटिव करना है ये लेकिन मेरा माइनस के पहले का आ गया 0 पे ही है
एक नंबर
क्या
अरे मेरा आज 0 पे ही आ गया
मेरा भी है
इसका
नेगेटिव वाला 0 पे आ गया
आपने फिजिक्स में दिया अरे तू
इसका नाम कैसे
किया ना क्या बराबर यूनिट
एक यूनिट लिया
अब तो 2 - 3 क्या हुआ भाई 0
हां आ गई है
छोड़ रे
ले ले
ये आ गया माइनस से आ गया हो गया
उधर
ये गलत चीज है तो ये सच्चे है ये 2 प्लस हां 2 प्लस है
अरे ये भी तू होगा मत कर तेरे दिनों की जरूरत है
अरे ये क्या बना
हां ये डबल लाइन कर जाते हैं
ये इरेजर में
हां भाई ये होमवर्क में क्लास में
ये मैंने किया हुआ था
लाइट
अरे बेटा ये पीछे
क्या है रुकना
ये ना मैं रे उसे पढ़ना से सॉल्व वो सर पढ़ के आए हम लोग
मैंने एक्टिविटी 8.3 किया
सर टेक्स्ट की है
एक बार मैंने पढ़ा
बेटा क्लियर हो इधर देख इधर
10.2
सॉल्व भी किया मैं उसको सुन के साथ निकाला के क्यों आती है वो स्वाति भी आती है
स्वाति से कॉपी करता है ये भाई का प्लीज सुनना
अरे परपेंडिकुलर तो बना 1 मिनट में तो कर क्या है प्रोट्रैक्टर से परपेंडिकुलर करने
Good evening.
Good evening, sir.
Where did we stop in the last class?
So we do the example 8.1.
Example 8.1. Eight point one, 9.1.
I have to go with it.
Acha, 8.1. This is our third lecture or fourth? Huh? Third lecture. You are saying we did example 8.1. Did we begin with velocity?
Yes, sir.
We defined velocity already.
Yes, sir.
Okay. ठीक है. Had I given you any homework?
8.2 and 8.3 read करते हैं.
Read करने बोला था. किया सबने?
Yes.
Okay. Any doubt in that? Huh? Anybody want me to do it for you? किसी को doubt है? 7.1 and 7.2 and 7.
8.2.
सबके पास old book है क्या?
नहीं.
इसलिए बोल रहा हूँ ना, इसलिए. न्यू बुक में 7.2 आएगा, 8 की बजाय 7 हो जाएगा. ठीक है. अच्छा, ओपन यूटी वॉल्यूम पेज 164. Did we do all these questions? Speed and velocity.
8 तक किए.
नहीं, उसमें कौन सा क्वेश्चन था? What does the path of an object look like when it is in uniform motion? ये क्या है? UT volume page 164.
Question.
I'm reading the question. Distinguish between speed and velocity. Have we done it?
नहीं.
नहीं किया ना.
This will skip that question.
अच्छा, we skipped that question.
Till question number 6 we did. अरे
अरे ये skip किया था आगे का केवल.
Skip किया था क्या? ठीक है. तो we'll start with this. ठीक है. So it will also revise what we have done up till now. So the first question is, I am reading from the textbook. You see what question number is that? Distinguish between speed and velocity. You'll raise your hands and then we'll do. So it is the difference between speed and velocity. Who will answer? First difference. Speed is
distance covered in unit of time.
correct. So it is distance upon time. Distance covered in unit time, we call it as speed. What about velocity?
Displacement.
Yes, it is displacement. So displacement in unit time. That's called velocity. What is the second difference?
Scalar.
Scalar and vector. Okay. Any other difference?
Magnetic.
This is the meaning of scalar. So it will have magnitude only. That is scalar. That is magnitude only. And vector, that means it has magnitude and direction. Okay. So last, any idea what is the unit of both? There's no difference. It has same unit. This is also meter per second. This is also meter per second. Okay, and direction. So that's not unit. You have to specify direction. Okay. So till here everybody is okay. Under what conditions is the magnitude of average velocity of an object is equal to its average speed?
That is a
We did that. So when is that?
Straight line.
So when the motion is taking place in the straight line with varying speeds. Okay. So but the direction is not changing. It is just continuing in one direction. Okay. So what does the odometer of an automobile measure? Did we discuss it?
yes.
Odometer. So what does it only measures the distance? Does it also show what is the speed?
No.
No.
That is no.
That is speedometer. Correct. So the vehicle meter has both. It has the odometer, which appears as numbers. Okay. The number kilometer will appear here. So that is odometer. And then what it has? It also has another meter which says what is the speed. Okay, like that. So 100. So it has both the speedometer, which is this, and the odometer, which gives the distance covered by the vehicle till date. Okay. What does the path of an object look like when it is in uniform motion? Yes.
Straight.
Uniform motion. What is uniform motion? Uniform motion means when the object is covering equal distance in equal interval of time. So that is uniform motion. So what does the path of an object look like when it is in uniform motion? Straight line, because velocity is also constant. And if the direction changes, velocity changes. So velocity cannot change. So its direction also has to be fixed. So that is uniform motion. I think we discussed earlier. Huh?
Yes.
Then during an experiment, a signal from a spaceship. Did we do this?
Yes, sir.
Acha. So that's what I was
One.
asking. Okay. Now next example 8.2 from NCRT. How many of you have done this question? 7.2. The odometer of a car reads 2000 km at the start of a trip and 2400 km at the end of the trip. If the trip took 8 hours, calculate the average speed of the car in km per hour and meter per second. So the question is example 8.2 from the old book, okay? Or 7.2, whatever. So initial odo reading. So what is given? Initial odo reading. Let's call it S1. How much is 2000 km? Then final odo. Let's call it S2, 2400 km. Okay. So therefore, what is the trip distance? Therefore, trip distance is
400.
trip distance is final minus initial. S2 minus S1. Okay. So this will be 2400 minus 2000. So 400 kilometers is our trip distance. Now time taken for the trip is 8 hours. 8 hours. Okay. Now for this motion, you have to calculate Average speed and so average speed. First in kilometer per hour, then in meter per second. These two speeds you have to find out. Let's solve it. So first case, what is the formula for average speed?
Distance.
Yes, total distance upon time interval. So total distance is 400 kilometer, right? So 400 kilometer upon time is 8 hours. So this is the answer in kilometer per hour. How much is this? 50 kilometer. Okay, 8 points on. Okay, now how will you calculate in meter per second? Same thing. Average speed in meter per second. So it was 400 kilometer, right? Upon 8 hours. So convert kilometer into meter. How much is a kilometer in meter?
1,000 meters.
1000 meter. And this is how much second is an hour? 60 into 60, 3600. 1 hour has how many seconds? 3600. Okay. So what do you get? These two zeros cut. 2 5s are 10, 2 18s are 60. So any kilometer per hour can be converted into meter per second by multiplying 5 by 80. So 400 upon 8 into 5 by 8. Understood? Now this answer will be meter per second. To convert any value in kilometer per hour into meter per second, you just have to multiply that by 5 by 8. So 400 by 8 was already 50. On it. Now calculate how much you will get. So this will be 9. 125 divided by 9. So how much is this? This is 9 ones are 9. 35. So 9 for 9 3s are 9 3s are 27. So 8. Right. So 8. How much is that? Is it correct?
13.9.
13.9, right? I think 13 point it will be 88. And then when you round off, you'll get 9. Okay, when you round it off, you'll get 9. Because the balance comes 80. 9 9 is 81. So it will go 8 times. Okay, so this is the final answer. You can write it as either 13.88 or 13.9 meter per second. It's up to you. So this was example 8.2. Next is, let's do 8.3 or 7.3. Are you done writing 7.2? So this is from the new book. Okay, 7.3. 8.3 is from the old book. The number. Shall we discuss 8.2? Sorry, 8.3. So it says Usha swims in a 90-meter long pool So how long is the pool? 90 meters. She covers 180 meters in 1 minute by swimming from one end to the other and back along the same straight path. So what is the distance covered? So this is 90 meter while this way plus 90 meter. So let's say it is AB. So A to B 90 meter and B to A again 90 meter. Total 180 meter. How much time she takes? 1 minute. Okay. This is the situation. So the pool length is 90 meter 1 minute. So she goes like this and then again comes back. Find the average speed and average velocity. So you have to find average speed and you have to find average velocity. So what will be average speed?
Total distance covered.
Total distance is 180 meter,
Total time.
which is 1 minute. So 1 minute is how much? 60 seconds. Right? You have to write the time in seconds. So you can write 60 seconds. So this is how much? 3
Yes, 3.
meter per second. So the average speed is 3 meter per second. What about velocity? Average velocity?
Displacement.
So what is the displacement? Displacement will be 90 minus 90. Displacement is 90 in this direction and minus 90 while coming back. 0. Okay? Everybody knows this?
Yes.
Plus 90 minus 90. So what is displacement? 0 upon 60, which is 0 meter. So for the same motion, average speed is 3 meter per second, but average velocity is 0 meter per second. Okay. So now we'll go ahead. We'll begin with the next topic, which is rate of velocity. Rate of velocity. So everybody is familiar with rate of motion, right? When we studied about rate of motion, what did we study about? When we say rate about anything, what does it mean? When we say rate of motion, it means how motion is changing with time. Motion is represented by distance covered. Okay, so that relation, distance covered in a given time, describes motion, whether it is fast or slow. Now we are saying rate of velocity. Meaning what? When I say rate of motion, what was changing? Motion. When I say rate of velocity, what is changing? Velocity. So it represents change in velocity with time. Okay? Is the velocity increasing with time or is it decreasing with time? Increase or decrease, both are change. Got it? So rate of velocity is basically acceleration. What do we call it? Acceleration. Okay? So how do you define acceleration? So rate of velocity. Acceleration is defined as change in velocity of an object in unit time. Okay, that is A is equal to V minus U upon T. Okay, where V minus U is change in velocity. E is final velocity. U is initial velocity. Okay, T is the time interval. And A is acceleration. Okay, so what is V minus U? Change in velocity. Okay. So at the beginning of the motion, what was the velocity? What was the velocity? U.
U.
And what was the time at the start of the motion? 0. Right? That's why we did not write T minus 0. It's understood. T means T minus 0. Okay? What is T? The total time interval, time duration. So start is 0 and whatever is the time. Clear? Now. So now some more terms. When velocity increases, okay, then acceleration is called positive. Okay? Let's say when the vehicle is moving with some velocity and we say we are accelerating it, and after acceleration its velocity will increase. Okay. So when velocity decreases, then it is negative. Okay, it is called negative acceleration. So there is a term for it. So when velocity increases, it is called acceleration. And when velocity decreases, then it is called retardation. Okay. So what are the example of acceleration and retardation? Can you give me an example? Can you think of an example of acceleration and retardation? What is acceleration? When the velocity is increasing. So, have you ever experienced increasing velocity situation? When you sit inside the car, that time it is at rest. Okay? When the driver starts driving the car, then it is accelerating, because first it was 0, speed was 0, I mean velocity was 0, now its velocity is increasing. So how much you will take the speed to or velocity to? Say 30, 40, 50, 60, फिर 80 तक जाएगा. उसके बाद जो भी कार में बैठा चिल्लाने लगा, और मत पड़ा, चिल्लाते सब लोग, बस हो गया अभी चलो, है ना, होता है ना. फिर एक्सप्रेस वे पे कितना जाएगा? 100, 120 भी जा सकता है. तो 0 से जो 80 तक गया, उसको क्या बोलेंगे? एक्सेलरेशन. ठीक है ना? So that is the example of acceleration. Retardation क्या होगा? तो ब्रेक मारेगा धीरे धीरे, यहाँ पहुंच के रुकना चाहिए ना. ये घर इधर दिख रहा है उसको, यहाँ से आया और ऐसे ही चला गया, रुकेगा कि नहीं? स्पीड ब्रेकर भी होता है रिटार्डेशन. तो तुम क्या करोगे? ब्रेक लगाओगे. सो देखो, जो तुम जब एक्सेलरेट करते हो, एक्सेलरेटिंग कार, एक्सेलरेशन ऑफ अ कार, ठीक है, उसका टर्म ही एक्सेलरेशन है. मतलब समझ जाओ उसका क्या हो रहा है? वेलोसिटी इंक्रीज हो रहा है. और रिटार्डेशन क्या है? ब्रेकिंग ऑफ द कार. ब्रेकिंग नहीं, ये तो तोड़ना हो गया, ब्रेकिंग नहीं. BRA, जस्ट BRA, application of brakes, braking of a car. So be careful, don't say brake the car. कार टूट फूट नहीं आना चाहिए. You are just braking, applying brakes. समझ आ गया? अच्छा, और एग्जांपल. ये कैसा एग्जांपल? Accelerating, है ना? So this is any free falling object is an example of acceleration. Why is it accelerating? Why the velocity is increasing? Force of gravity. Okay. So gravity का acceleration कितना होता है? G, small g. सुना है? Any object that falls towards Earth accelerates with G. ठीक है. ये हो. ठीक है. So the first example was on the ground. Second example is example freely falling object under gravity. ठीक है. So let's say you have an object and it falls down. What is the acceleration? We don't represent acceleration due to gravity by A. We represent it by G. ठीक है. So remember this. G is acceleration due to gravity. So this is like observed phenomenon. So you'll read about it, okay? And its value is given as, so G value is 9.8 meter per second square. Right? Why meter per second square? Because see, the numerator is velocity. So it's, what is the unit of acceleration? Velocity in the numerator and time in the denominator. So this is meter per second and one more second in the denominator. So when it goes up, it will become meter per second squared. What is it? Meter per second squared. Okay, because it is velocity upon time. So unit of velocity is meter per second. And upon time, so वो वाला second ऊपर जाएगा तो क्या हो जाएगा? Meter per second squared. Okay, so Don't be confused with the unit of velocity and acceleration. Okay? So any falling object will experience this acceleration. So its velocity. Now what was the velocity at the top? What was the velocity? 0. Because as it started falling, it is stationary. What is the velocity of stationary object? 0. Now it start increasing, it will hit it with maximum velocity. Okay? So just before it hits the ground, the velocity is maximum. When it hits the ground, hits with V is maximum. Okay? So this is the example of acceleration. Accelerates. Now what is the reverse case in the free fall? Yes, toss it up. What is happening? When the body is going up, what is happening? What is increasing? When you throw, velocity is increasing. Are you sure?
No, sir.
Gravity always acts downwards. So how can velocity increase? This is the reverse case, where at the time it leaves the palm, its velocity is maximum. So it's like it's trying to go up and somebody is pulling it down. So right from the start, when it leaves the palm, its velocity continuously decreases. Now the slow motion will be like this. At the top, stops. For some body to stop, its velocity has to continuously reduce. Isn't it? Only then it will become stationary. Then it will start free fall. Got it? So this motion of free fall, observe it again. Maximum velocity and then least velocity, which is 0. Then again it comes back. So it actually, when it reaches the ground or when it reaches the palm, with whatever velocity it was thrown up, it hits the palm back with the same velocity. Why? Because it is subjected to same acceleration. The acceleration which was downward, it is same acceleration when the object is falling again. Got it? So just keep these concepts in mind. It will help you in the next chapter. So now, example of retardation. When object is thrown upward, object is thrown upwards. Its velocity continuously decreases. That is retards. Yes.
So then, in which case this will come, like
In this case?
during skydiving, when we jump into the sky and when coming down, the parachute opens. So it will be acceleration or retardation?
So what the parachute is doing?
The parachute is decreasing the speed, but still it is coming down because it is moving.
Yes, because now there is a resistance. See, your body surface area is very less. So there is a chapter on pressure and there is upthrust concept. So when the parachute opens, its surface area is much bigger than your body surface area. Our body is hardly 1 square meter, one side. Okay? So, but the parachute is very big. So the air resistance that will kick in. And your body weight will not be able to fall as it was falling earlier. So it will slightly reduce the effect of gravity. Because now there is an upward force.
So that will be the retardation.
That will be like there is a net force. It's not just retardation. It's like there is a body. Let's see how many forces acting on you. Let's say somebody is falling, and there is a parachute. So what happens? Parachute is very big, right? So there is the air which was coming below you is not getting sufficient area to block you. But the parachute is very big, right? So even if you must have observed when you are carrying a umbrella, wind is blowing. You just if you're without an umbrella, wind doesn't affect you much. But with the umbrella, it's very hard to control because it gets a larger surface area. So the effect, the force of wind, okay, that effect is felt over there. So here what is happening is this air is getting a much larger surface area too. So air friction is there though. So because of that, you are not able to drop with that speed. And on the contrary, if you are a trained paratrooper, you can control the landing, you can navigate your landing also. So that impact, which is a vertical motion, it can be reduced. You will get enough time to straighten up and then produce proper landing so that you don't break your bones, right? There's a training for it. So you'll understand it more when we have covered that chapter, pressure and there is something called as upthrust. So you need to know this to understand how it functions. So all this is coming. So have I answered your question? Kind of. Your question was whether it is acceleration or retardation, right? With parachute, the retardation increases. Okay? While free fall, when you are in free fall. Retardation. What else? It may not be even a case of retardation, it may be a case of uniform motion. Because what if there is no acceleration at all? The body can move without an acceleration. What is uniform motion? Velocity constant. So velocity constant, velocity, there is no change in velocity. So there is a motion without acceleration, right? When you start cruising, car 80 पे पहुंच गया, उसके बाद 80 पे ही चलो, then there is no acceleration. But is there a motion? यही समझना है फिर. ठीक है? When we say acceleration, there is change in velocity. No acceleration does not mean no motion. ठीक है? चलो. तो ये धीरे-धीरे होएगा, क्लियर होएगा. ये फर्स्ट चैप्टर है, इसलिए थोड़ा टाइम लगेगा. Too many new concepts are coming.
Because by using parachute, we are still experiencing the force of gravity.
Because that is always there. No? There is a force of gravity acting on us. But are we getting into the ground? No. Because why? There is an upward force of reaction also. So next chapter, force and laws of motion, all those things. Okay. So restrict, hold your craving. Good. You are able to think ahead. So which is good. Is gravity not acting on me right now? It is. If it was not acting on me, I would have been floating in the air. Okay? So gravity is important. It is holding me onto the ground. So it's working now. Slowly people are asking questions, means good. Okay? Now I've lost track. What was I explaining? So we did the free fall, which is the acceleration due to gravity. Now the reverse is retardation. Why? Because gravity is still down. Gravity will always act downwards. Hence, this motion of the pen. Motion of the pen is which type of motion? Retarding type of a motion. Because its velocity is continuously decreasing while going upward. That is why at the top its velocity becomes now 0. Once its velocity becomes 0, meaning once it becomes stationary, is gravity stopped acting on it? Gravity is always acting. So then where will it go? Down. Okay? So So this is your. So there is an activity given in your book. So I'll read this activity. In your everyday life, you come across a range of motions in which acceleration is in the direction of motion. Can you give me 2 examples? When the acceleration is in the direction of motion, then the velocity will. Achha, whenever you are saying acceleration, always use the term velocity, don't use speed. Because acceleration is also a vector quantity. Acceleration is in the direction of motion. In what case? When the velocity is increasing and during the free fall. Okay. Acceleration is against the direction of motion. Braking of the car. When you apply brake, motion is ahead, but now you are applying brakes. So where is the acceleration? It is negative acceleration. Okay. And when the object is thrown upwards. So this is how you will be able to answer the activity questions. Okay. C. Acceleration is uniform. Now what is uniform acceleration? Next term is uniform acceleration. What is the meaning of the word uniform? Constant. Now the acceleration is constant. What does it mean? Velocity is increasing at a constant rate. This is what it means. When the acceleration is constant, velocity of the body is increasing at a constant rate. Okay. So what is the example of uniform acceleration? Let's say car started at 0. In 1 second, it reaches 10 km/h. Next second, 20. Again, next second, 30. So in 5 seconds, it reaches 50 km/h. 6 seconds, 60 km/h. Okay. So that is, what is the constant increase? 10 km/h in each second. Then it is uniformly accelerating. What about freely falling? Is it an example of uniform acceleration? Yes. This is also like constant acceleration. G value does not change throughout the fall. G is constant. When the objects are near the surface of Earth, of course, not very far away or not too deep inside the ground. Okay. So this is also constant. G value is a constant. Constant. Here, surface of Earth. When I say near surface of Earth, मतलब 10 किलोमीटर ऊपर है तो भी उतना ही level. Because Earth is very big, right? So in that sense. तो समझ आ गया? So what is uniform acceleration? I just explained, right? When the acceleration is non-uniform, give me an example. When the car is navigating through traffic, sometimes when there is free road, it accelerates. Okay. When there is traffic, it slows down a little bit. So it is not like increasing at 10. Sometimes 10, sometimes 5, sometimes 3, like that. Okay. So, and in ideal life situation, the motion is uniform or non-uniform? In our daily life, non-uniform. So, the uniform thing is only a definition, ideal concept. Ideally, it should have been like this. Okay, but it never happens like that. So, always it is non-uniform. All right, can you identify one example of each? We just did that. Next question, 8.4. Let's do that. You have written this side?
Yes.
So are you understanding till now? So physics is a very conceptual subject. So once you start getting the meaning, then you'll catch it fast, and all the numericals will be able to solve. Right? Few words combined with mathematics. Now the mathematical part. So it is example 8.4. Let me read this for you. Starting from a stationary position. Hear me out. Starting from a stationary position, Rahul pedals his bicycle to attain a velocity of 6 meter per second in 30 seconds. Right? So what is given? Given stationary bicycle. Stationary bicycle. Stationary bicycle. What was the speed? That is u is equal to 0. Isn't it? Initially the bicycle was stationary. Now he pedals and brings the velocity to 6 meter per second. Okay, there are various scenarios. So first case is this, case 1. Final velocity of the bicycle is this. What is the time taken to reach from 0 to 6? This is how you should solve numerical. First, write down the data. T1 is 30 seconds. Okay. Then, so in case 2, what happens? Then he applies brakes such that the velocity of the bicycle comes down to 4 meter per second. Now velocity comes down to 4 meter per second. So what is V2? 4 meter per second, final velocity. What is the initial velocity in this case? The final of the first case. Correct? Got it? So this is how you should be able to catch data. मतलब 6 मीटर तक तो पहुंच गया, उसके बाद he applied brakes. Now the velocity is 4 meter per second. In how much time he brought the velocity to 4 meter per second? In 5 seconds. Okay. So now what you have to find out? Calculate the acceleration of the bicycle in both cases. So find A1. A1 is equal to what? A2 is equal to. So find out. Find out A1 and A2. What should be A1? Okay. And what should be A2? Four minus 6 is 1 by 1. Is it correct? Some mistake I have done. 4 minus 6 is 2. Minus 2. This is equal to how much? Minus 0.5. Okay, everybody understood? So now tell me, what type of motion is that? 1 and 2. Yes, this is positive. So it is a accelerated motion. This is negative. So it is a retarding motion. Retardation. All right. Then we'll do some more questions. Now you can open your volume. I think page 164 or 165 you get it. So continue. When will you say a body is in uniform acceleration? Let's see these questions. 164 or 165. When will you say a body is in uniform acceleration? Just discuss it. When will you say a body is in uniform acceleration? Which phase is that? 165. When the velocity changes at a constant rate, increases, right? Or decreases. It is just saying acceleration. So changes, right? So change could be increase or decrease. So when velocity changes at a constant rate, it is uniform acceleration. And when it is not, then it is non-uniform motion. Correct? Sure. Try the second question.
If it is a uniform acceleration, so we can write it as velocity changes at equal interval of time and equal distance like this.
When you say velocity value is bringing in distance. So when the velocity of the body changes at a constant rate, then it is uniform acceleration. Okay. And when it does not change at a constant rate, then it is a non-uniform acceleration. Second question. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. Now there is a unit conversion involved. Time is given in second and velocity is given in kilometer per hour. So either you convert velocity in meter per second or you convert time in hour. Both ways you can do it. Okay? So get the answer. Minus. So in the question. No, that's like below denominator. You mean kilometer per hour, right? This minus. This means it is kilometer per hour. This is what it means. So it can also be written as kilometer per hour. I told you. So this is a case of acceleration or retardation? Retardation, because it is decreasing, right? But it has said find the acceleration. So acceleration means it should be negative value, correct? Got it? So a positive acceleration means acceleration. A negative acceleration means retardation. It's like so it is in-text question 10. I don't know which question is that in your volume? 10. Page 165. So it is U is, how will you write? Are you writing First, the given data, given u is equal to 80 km per hour. Make a habit of writing the given data before beginning solution. Then there will be less mistakes. V is equal to 60 km per hour. Okay, and time is given in second as 5 hours. Okay. Solution. So if I convert time in hour, that will make my calculation easy, right? So how to convert time in hour? How many hours is 5 seconds? In 1 hour, how many seconds are there? 3,000. So just divide it by 3,600. Okay. So this means 5 divided by 60 into 60. These many hours. Okay. So now, so what is acceleration? A is equal to V minus U by T. What is V? 60 minus 80 divided by T was 5 upon 3600. Okay. So what do you get? You get 60 minus 20 into 3600 divided by 5. And what is the unit now? Kilometer per hour square. Okay. It will be kilometer per hour squared. So how much is this? It's 5 seconds or 5 minutes? So then 5 fours are 20. So how much is this? Minus
144.
4 6 are 24. So 144. So it will be minus 1.4 into 10 raised to 4 kilometer per hour. Or 1.44, whatever. In rounding off, you can get rid of 4 because it is less than 5, so it will not affect anything. So this is the answer in. What if I would have asked you to bring the answer in meter per second square? Then what will you do? Meter per second square. Then see, then what will you do? You leave time as second only. You will make a conversion here. So what it is now? 80 into 5 by 80. That will give you meter per second, right? And here it is 60 into 5 by 80 meter per second. Correct?
Yes.
Remember, kilometer per hour, if you have to convert in meter per second, what you have to do? Just multiply by 5 by 80. Because kilometer is 1000, hour is 3600. So when you cut it, the most simplified you will get is 5 by 80. 1000 by 3600 is 5 by 8. Okay. So now you can do this calculation also. Or A is equal to, so what is it? So write it down. So it will be 60 minus 80. Whatever you get. Okay. So this is a homework. Do this calculation as a homework. Homework. Find A in meter per second square. Okay. So get habituated of doing these calculations. With time you will become fast. Sure. Thank you.
This is equals to max और इसमें थोड़ा आपको स्पीड में पढ़ते हैं बाकी सब कैलकुलेशन आगे करें वो वाला लेसन आज कौन सा डायरेक्ट निकाल वो लेसन निकाल बाकी कुछ मार्क्स सर मैं अटक कर सर बार-बार इधर देखते हैं